Testing, testing. Cool. Getting some Leetcode. Let's see, what was the name of the problem we're gonna be solving today? Gonna be not group anagrams, but top K frequent elements. Okay. Oh, we got 30 minutes. Given an integer array nums and an integer k, return the k most frequent elements. Okay. So the question is the array, so the array wouldn't be, I mean, wouldn't this be pretty simple? You can just create a hash map, have the, no, because then you don't know the top most frequent elements. I guess you can keep track of frequency of all the elements, couldn't you? You can keep track of the frequency of all the elements and then sort them and then grab however many, like whatever k is, grab those first elements, I guess. Look at the topics, right? Divide and conquer, sorting, heap, priority queue, bucket sort, counting, and quick select. I don't really know much about those. So I guess before we do this, heap. What is a heap? So look that up. What is a heap? Special kind of binary tree that satisfies two properties. Min or max heap. Let's say, explain it to the point where I can code one from scratch. So I guess before we solve this problem, we're gonna go create one of these from scratch. Let's go. I'll walk through exactly what you need. Array representation, parent at index I, left child equals 2i plus 1, right child equals 2i plus 2. Parent of child at I equals math minus 1, 2, insert value, bubble up. I also need bucket sort. Bucket sort, heap. Am I even ready for this question? I mean, it is array and hash table. Yeah, heap would be just on big screen. I think we're good. Okay, so we're gonna we're gonna watch a video on heaps, right? Heap explained. Watch a quick video on it, and then we're gonna code one.
To make a great first impression.
Today we're going to learn about heaps. You often hear the word heap when discussing storage for garbage collection in languages such as Java. But this video is about the heap data structure that is used to manage information. Heaps are sometimes called binary heaps and are nearly complete binary trees. Here's an example of a heap. By a nearly complete binary tree, I mean that all levels are filled except the lowest, and the lowest level is filled up to a certain point starting from the left. Uses of heaps include heap sort and priority queues. And there are two kinds of heaps, max heaps and min heaps. On the left, we have a max heap. The condition for a max heap is that the value of the node I is less than or equal to the value of its parent. Max heaps are used for heap sort. Similarly, for the min heap, the value of
They don't get what heap is.
Hi, I'm Gail Locke-McDowell, author of Cracking Coding Interview. Today we're going to talk about a topic that a lot of candidates forget about, heaps. Heaps.
Yes, let's go to Leetcode. See what he has on there. I don't think that because that's like graphs. Like, so why is that under arrays and hashing? So down contains duplicate, valid, anagram, and top K frequent element. Okay, so get it though.
Heaps come in one of two forms, a min heap or a max heap. We'll just focus on min heaps today because a max heap is essentially the reverse. In a min heap, the elements are all smaller than their children. So the root node will be the very smallest element. And then looking down the tree, down the heap, the elements get bigger and bigger and bigger. So that's the basics of what a heap is. But how do we actually create and maintain such a data structure? So let's start with just insertion. So when we insert an element, it always goes in the next empty spot, looking top to bottom, left to right. So we go, first we insert an element here, and then here, and then here, and then here, and so on through the tree, through the heap. So that's how insertion works, but then, of course, what happens if that's not really where the element should go? Well, what we can do is we can insert the element there, and then bubble it up until we get to the right spot. So we take the inserted element, we compare it with its parent. If it's out of order, swap them, and then keep going up the tree in this process.
My name is Josh Carrion. I founded Legacy Roofing in 2018. I was raised in West.
Now, what about removing the minimum element? So we know the minimum element will always be at the root node. And so that's easy to find, but then if we want to remove it, we might have an empty spot. So what we do here is we remove the min element there. So we take out the root, and then we swap that value at the root with the last element added. And then, of course, that element might not be at the right spot. So we take the root element and bubble it down to the next spot. So we compare the root with its children, its left child and its right child, and then swap it with the smaller of the two. And then we keep going down the tree until the heap property is restored.
Okay, so you only care about, okay, priority queue. Okay, so it looks like a graph or a tree, but it's not a tree, right? Because a tree would be focused on traversing through the tree, right? But with a heap, you're focused on max or min, which is why there's min heap and a max heap. Okay. I think I see how this works. You use bucket sort on the heap in order to get the top K most frequent elements. I think so. I think that's how that works. Gotta solve it. Okay, so given an array enums and an integer K, return the K most frequent elements. Okay, so what do we need to do? We need to get the amount of each element, right? Get amount of each element, right? Well, I guess we should start with the biggest issue, right? Which would be to get the K most frequent elements, right? Well, how do we do that? Well, first we have to get the amount of each element, right? So first, our first goal should be get the amount of each element. And by doing that, what do we have to do? We have to loop through the array. We loop through the array and save each, what do you call it? Count inside of an array. So that's how we do that, right? So what's the next step? We have to get the most frequent elements from that array. I'm gonna go get my grokking algorithms book and see if it has sent on bucket sort or anything like that. I'll be right back. I have this book. See quick sort. I don't see bucket sort. See a lesson on do see a lesson on min heaps and priority queues on page 261. Our data structure built using trees. These heaps store a bunch of numbers. Here's an example of a min heap. Min heaps let you get the smallest element in the heap quickly since the smallest value is always the root. This is the main usefulness of the min heap. You can look at the smallest element in 0, O of 1 time, or in O of log n time. You can remove it from the heap with a new min in its place. Heaps let you sort very quickly. Keep asking for the minimum value and keep putting the values in order. At the end, the tree will be empty and you will have a sorted list of numbers. This algorithm is called heap sort. Max heaps are very similar to min heaps, but now the root is the largest value. Wait. You can loop through. You loop through the array. You try to keep the max value at the very beginning. Right? Then you just splice the array, and then you get the k most frequent elements. Right? Wouldn't that be correct? Just using heap sort. Right. So we loop through the array and save each count inside of an array. So what we can do, delete this. Say we can create an array. Say element count equals an empty array. And then we can loop through the array, right? So we can loop through nums. And in that array, let's just say we've been doing it for 8 minutes. We'll go until 14. Wait, no, not 14. 22. I was gonna say loop through nums. In every iteration, we loop through our heap. But no, that wouldn't really work really well. Because then that'd be like O of n times n times m, something like that, which really isn't really. The algorithm's time complexity must be better than O of n log n, where n is the array's size. I say we just look at the solution for this one and learn. Like this will be a learning one, honestly. I do have a brute force solution where we kind of, so we'd have an element count, and then we'd have a like an object, I guess, that stores the largest number in the array, in the element count array. Or I guess it would be minimum. I guess we should do minimum for this one. And then the index of that element, right? In every single iteration, what we do is we check if, oh no, that wouldn't work because we're not getting the count from each one. We're getting the count from, dang. Just got a whole lot more. I say we just look at the solution for now. I'm not going to be able to solve it. I already know. With TypeScript, simple solution, merge sort solution beats 70%. Priority queue plus hash map. Okay, so create a heap, new max priority queue. Priority comparator. What? He's creating a new frequency, right? Where I'm guessing the number, first number, right? The key will be the actual element in the array, and then the value will be the frequency. And then he's creating a new bucket. How do you use that constructor? Let me see. It's whatever you put in the array. So this creates an array of undefined. Is it undefined? Yeah, it's undefined. Of length nums, length of nums plus 1. Why is it plus 1 though? And then for I, right? And it loops through. Okay, and then it turns them into empty arrays. Okay. And it counts the frequencies for I, for num of nums. If frequency dot has nums, has that number, then frequency, or if it doesn't have that number, it'll set that value of that key to 1, right? So it just initializes it, right? Else it'll set it to whatever number it was plus 1. And then it fills the buckets, right? So for let num count of it just loops through the key value pairs in frequencies and then pushes it to the buckets of that count. How does that work though? What's the reason to create the empty arrays if you're not going to set it to that? Because this is just count. Okay, so it gets rid of those. It gets rid of the empty arrays. So what's the reason to set them? What's the reason to loop through the array right here and set the empty buckets? the array is of length 1. And tomorrow we'll come back to this question and try to solve it on our own. So, what is the pattern here? Index in the array represents the frequency. Okay, so that's why he's referencing bucket count dot push the number. Now, if you lose this, that's the greatest comeback in history, like LeBron in 2015. What? Only get one shot? Ooh. Oh, I don't think I can say that on here. Whatever. I'm not monetized anyways. I'm streaming. Hmm? I said the G word.
This might be the best website to learn new tech skills and how to code. This is Codecademy.
What's up, everyone? In this video with media TypeScript file, content with media, start with our content with media block.
Config, and you can see here's some more fields. We have a type, the hero type right here. This type has a couple different options, and the content tab just has this one layout field, right? And that one layout field, if I look at that, here it is, layout, and we've got a couple blocks tied to this layout field. So this is the block-based layout builder where we have 5 different blocks registered, able to be used. I can show you that. If I click on add layout, here's the 5 blocks that I have available to create my pages. I could register another one easily. Like I don't like how ESLint is taking my spaces out. I like these spaces. But I could add another block just like going like this. Slug, my new block, fields. You put, here's the call to action block. Here's the config. We're going here, we're all happy, we're gonna get one page. So those redirects. This comes out of the box. You really kind of have to set this and then you can forget about it. But that's pretty boring stuff. Finally, we're at the fun part, which is React. I think that's one of the points of this website template is that you don't want to wire this up yourself. Just let us do it for you. And we're going to monitor this stuff and we're going to keep it up to date. This is a good redirects pattern because it statically caches the redirect responses. So it's not super expensive. Page type. I'll type an array. Everything real quick. This template has light and dark mode. And so we need to know on the client side, is being a vertical chunk, this being a vertical chunk, this being a vertical chunk, blah, blah, blah. Then your editors can mix and match these components into different orders. So you see, like I have the call to action down here. I can just drag and drop this, and now it's in the middle. Drag and drop it down to the bottom. I can delete it if I want by just removing it. And then editors can add and create pages at their discretion using a bunch of Lego blocks that you gave them that are all highly branded and deliberate. And this website just comes with these first 5, right? These are kind of example blocks. You don't need to keep these blocks in your code. You can delete them if you want. But really,
Still using these? Yeah, these are out. And Motion AI? Yeah, this is in. You're at Motion AI.
it's up to your design system to define the blocks that you use. And our own website is built like this. Our website is open source as well. It's a big website, so there's a lot of moving pieces. Maybe not the best place to start if you're learning. I think that the website template is the place to start if you're learning. But this right here is on that same type of layout block mentality. So this is like a layout block. This is like a logo grid. Here's a layout block, which is like a big featured image. Here's a layout block, which is kind of like a sticky highlight. Well, I don't even know what we called this one. Then we have a slider. Then we have this little feature that I can click on these different things and see the different features. Then we have a content block with a couple calls to action and then the footer, right? And so our own website uses this exact same structure that we've got in the website template here. And you can use this structure to build a very, very wide array of different types. Down below that, and the content tab just has this one layout field, right? And that one layout field, if I look at that, here it is, layout. And we've got a couple blocks tied to this layout field.
What's up, everyone? In this with media block.
A CRM shouldn't weigh your butt.
Open up the component.tsx file for your content with media component, and then we're going to export a new function that we're going to call content with media block. Of these may generate types, but I'm going to go ahead and just generate the types now, and you do that by typing in payload generate. So I can go with me block that. If it is, we're going to return a section that's going to hold a div for our content, and we're also going to have a next image component. Now, a couple of things need to happen for this image component. First, we're going to wrap it in a conditional check and make sure that the image exists. Next, we're going to make sure that the type of that image is actually an image and does not equal string. If all of that is true, then we can render the image using our block
Okay. Hmm. Why are you playing everything out, guys? You're about to change what? Variant. What is wrong with this? This was just working yesterday. Why is this acting like this? What does this mean? Column variant cannot be cast automatically to type enum landing blocks hero block variant. What does that even mean? Did it just delete it? Why did it delete it? Oh, okay. Okay, there we go. For some reason, the image is disappearing. I think it's still there. It's just really big. So I guess right here, I come down here. I can say, I can just set the height equal to 100%. Yeah, that's good right there. Yeah, that's perfect. But the thing is, okay, and then I could say height auto. Yeah. Oh, that's perfect right there. That's perfect. But the thing is, this font, I want this font to get smaller, right? So I come up here and I could say font size. Say we'll just control X that, and then we'll say clamp. We'll just say var a font size, and then we want extra small. Extra small. And then we want maybe 1 rem plus 2.5 width. Yes. Go bar. And actually we'll delete this and just control V. Bring it down to the smallest size. Check it. It's still at 16. Okay, so we'll go to our globals and see what's going on here. Size extra small goes up to small. Maybe let's go look at our other clamp. 2 rem. Okay, boom. Right whenever it hits mobile. Right, this isn't centered. And what is that? That is the content. So I'll come in here, check. Okay. Column, and I'll say align items center. There we go. Why is that affecting? If it's a position absolute, it shouldn't be affecting anything. Why is it doing that? That is why the is it doing that? It shouldn't affect anything else if it has a position of absolute. That doesn't make any sense. Why is it affecting the rest of the screen? Like, why is it scrolling? If I have it to a position of absolute, it shouldn't affect the document flow. That doesn't make any sense. Yeah, in a little bit. What time does it start? 5. Yeah, I'll be up there in a bit. I guess in my content. Pull in CTA. href equals CTA dot URL. How's that a mistake? What is a URL? Why can't you just have it be a string? Put CTA dot label. Failed to construct URL, invalid URL. How? It's 1632. Padding. See. 16 pixels and 32 pixels. We'll say background color bar. Color primary. We'll say border radius. And we'll say 8 pixels. No, we'll say color. We'll say bar color neutral light. Say background color bar. Oh no, I already did this. What else do we have to do? Oh, we have to do display of flex, then align items of center, justify content of center, and then what's the gap between these two? Eight pixels. Say gap. 8 pixels. And then in our hero module, come in here, say add use. We'll come into our TypeScript config, create one for styles. All right. Oh, all right. Styles. 8. Okay. Say dot slash source slash styles. I'm at the end for that. Oh, I guess that wouldn't really work for this. So never mind. We're gonna have to go slash style slash mixins. Then we'll come in here, CSX, and we'll give our button a class name of styles.hero underscore CTA. I think I should create a button component. I do have a button component. What am I doing? I already have a button component, so I didn't even need this. So what I'll do is I'll come in here. I'll import button. And then instead of rendering this button, what we'll do, we'll render a link. Link, and then in there we'll render a button component. Okay. In here we'll render we'll say href equals CTA URL, and then we'll give this a class name of styles dot hero underscore CTA. I guess we don't even need this. Then I guess instead of using the link, which probably just wouldn't be right, I can just give this an on click and then say I can just do redirect to CTA URL. Okay, on click, never is missing children in type. Okay, yeah. So that's in type, and it'll be a CTA. And then children will just be oh yeah, it'll be CTA dot label. That's humongous. Jeez. Hello.
So, calling you.
Hey, Momo.
How's it going? How you and your girlfriend doing?
We're doing all right. We're doing all right. We went to church today for Easter.
Oh, so they don't do that in that church. Church. Said one of them Baptist churches. I thought it was.
Nah, it's a Mormon church. So, I forgot that with you getting your truck, you don't work at that same job, so you don't have that insurance anymore. No, nothing, nothing really happened. It's just, I gotta get blood work done twice. And if I don't like go to a place that takes insurance, it's like $700 for just one time. And then I gotta get it done twice. No, I logged into the app and it said it's already taken away. It says it's inactive. It's inactive. So I just gotta get some New insurance. No, that was land design. That was the other company I worked. Yeah, I mean it's all right. I didn't know. I forgot that you're not working at that same company anymore. So it just caught me by surprise. Yeah, on the 4th. No, no. I gave them my insurance. It worked then. It's after that that the plan canceled or whatever. Try to apply. I mean, I guess. Are you talking about just generations later?
They told him, Dr. Angola told the Allen doctor they would doctor would doctor. I'm glad you came in. Allen.
I haven't started taking any medicine for lupus specifically. No, no, I just take medicine for the symptoms that I have right now. Yeah. Yeah. Mm-hmm. Kate got her Kate got her tax return or refund. She already talking about blowing it by going to Texas. Yeah, she really wants to come back to Texas. So bad that she wants to blow her $1,900 All right, guys, I'm going to go ahead and end the stream. I'll be back later in like 2 hours.